Hello guys, very good morning. Welcome back and let's start. So in the last session we discussed about the Terraform. We have gone through the Terraform introduction and what is Terraform and how we can configure the Terraform and how to install Terraform. These are the things that we have seen in the last session, right? So anything else that we have checked out?
Hi, Chaitanya. This is
Hi,
Kamal.
hi, come on.
Good morning.
Good
So,
morning.
Chaitanya, I didn't join yesterday's call, but I saw the videos. Um, you did most of the Terraform in AWS. I kind of simulated it in Azure and ran it. Would you be possible to give hints on how to do in Azure as well when you give the demo? Is that an option you have?
Yeah, I will try to give it out.
I kind of did some, but when I did apply, I got error. But other than that, it worked.
What are the errors that you got?
Oh no, we don't have to go in deep now because I can tell you, but it's error creating Linux machine and everything, but that's maybe out of scope right now. But
Mm-hmm.
when you're taking class, I know you focus on AWS, but if you can just say, oh, in Azure, this is how you do, so I can just kind of follow through.
So then I must have tell you in the Azure itself. Okay. So I will
If you
try to
can, that'd
explain.
be awesome.
Yeah,
Huh?
I will try to explain. Okay. It's not, I cannot guarantee you that, but yes, I will try to explain you on that. Okay.
Thank
Right. Uh, so in the last session, we have discussed about the provider VPC, how to create the VPC. And here we have checked out this is the reference name. So when we are applying this, then automatically what will happen? The VPC will be created. So this is what we have seen in the last session. But one thing that I just want to tell you here is CIDR. CIDR are the networking blocks. Okay, so whenever we are working with the VPC kind of configuration, we need to provide the networking blocks. So this is the network block. Simply, if I have to tell you, for example, if you are purchasing a home, or else if you are purchasing a piece of land, then what you are going to do? So this is for example, this is a very big area. So in that area, you want to purchase a piece of land. Then what you are going to do here is this entire area is like your network. Okay. So now you are going to divide this network into small pieces. Okay. So the entire land or else the entire what I can say whatever the area you are having land area that will be divided into plots. Okay, the venture whatever you are seeing that will be divided into small plots in the same manner in networking also. So whenever we are working with the subnetting, we are going to divide the very big network or else we are going to combine the network into small pieces. That is called as subnetting. So whenever we are working with the subnetting, either a small network can be divided into multiple into combination of a big network, or else a big network can be divided into small networks. So that process is called as subnetting. So the CIDRs will be applied in the subnetting perspective. So what is meant by CIDR means classless inter-domain routing. What does this classless inter-domain routing means? For example, first of all, basic thing is that you need to understand the networking concept. I'm not going very deep into that, but at least you must have a clear clarity about the networking. So that's why I'm telling you this. But actually, it is not required for you. Anyways, whenever we are discussing about network is the combination of connection of multiple devices together. Okay, connection of multiple devices together with a media in the sense either it might be a wide media or wireless media, or else like a cable, or else through wireless Wi-Fi and all the things. So that is called as network. So connection of two or more devices through a media is called as network, and establishing the communication between those devices is called as networking. Okay. Now how this communication will happen? For example, there are two computers are there in in a network, or else there are so many computers are there in a company. Now, one computer has to communicate with the another computer. How they will communicate between those computers, or else how the communication will happen between those computers. So, this is your computers. These are your computers, for example, in your working environment. So all the computers are connected through the cable. Okay, like switch, and there will be centralized device called as switch, and all these things are connected to the switch. And like this, what will happen? The computers will be in communication. So computer one will can communicate with the computer two. Okay, so now how these computers will communicate among themselves or else with each other. So to make the communication between the devices, definitely we need to have an IP address. Without IP address, it is not possible to establish the communication between the devices. There is a MAC address and everything, but without IP, we cannot make the communication between the devices. It is just like, for example, you have a mobile phone and your friend is having, your a group of friends are also having the mobile phone. So if you want to communicate with your friend, then definitely what is your requirement? So you need to have an idea about your friend's mobile number. That is very required. That is mandatory. If you don't know your friend's mobile number, then you cannot communicate with him. In the same manner, for example, computer one wants to communicate with computer two, then definitely every computer should have the IP address. Without the IP address, the communication will not happen. Okay. So now what is this IP address? IP address means Internet Protocol. Okay, simply if I have to tell you, IP address is an Internet protocol which will be helpful for establishing the communication. Okay, so how many types of IPs are there? There are two types, IPv4 and IPv6. IPv4 and IPv6. So we are still using the IPv4 only rather than going for the IPv6. We are still using the IPv4. But some companies are slowly, I mean, in some countries, slowly they are going migrating to the IPv6 also. But it is better to understand the IPv4. So now what is this IPv4? IPv4 is an 32-bit address. Okay, 32-bit address. So whenever you see your computer, in your computer, if you check the IP address, so every time when you check the IP address, you can see IP config. There are, see that 192.168.0.106. Like this, I have an IP address. So what is this 192.168.0.106 in the sense? So these are the decimal number formats. So this is the decimal number of IP address. 192 is a decimal number. 168.0.106 is a decimal number. So here I said you 32-bit address. 32-bit address is in the form of binary number format. So you will be having 8 bits in an octet. Okay, 8 bits in a portion. Like this you will be having. Now these 8 binary bits are converted into the decimal format. Then you are going to get this particular number. Now, what is this 8 bits? So these 8 bits, I mean, if you see here, IPv4 is a 32-bit address. The entire 32 bits are divided into 4 portions. Now, every portion will have 8 bits. 8 into 4, 32 bits. So now that portion is called as an octet. So whatever the portion that you are seeing here, this is called as an octet. Octet means 8. So 8 bits in a portion. And if you convert that binary bits into the decimal number format, so you are going to get a value that ranges between 0 to 255. So in every octet, you will be having a number that ranges from 0 to 255 only. Apart from 255, you are not going to get any number, like 256 number will not be there in the IP address. You can check it out. Any IP address you take, so that range will be starting from 0 or it will be end with the 255. 0-255. So like that. So now when we are having this kind of IP address, so how we are going to understand this particular computer belongs to this particular network. So for example, here I am having a computer. This computer 1 is having the IP address 192.168.100. Okay, so this is the computer 1 IP, and the computer 2 IP is also somewhere like this 192.168.1.150, and computer 3 IP address will be 192.168.2. Some 200 is the IP address of computer 3. Now, how you can understand that all the computers belongs to the same network or different network, depending on what you are going to say that the computers belongs to the same network or different network. So there is a number format is there. Okay. So when there is a number format, so we can see that these computers are assigned with these IP addresses. Now, depending on what you are going to say that these IP address belongs to the same network or different network. For example, when you are attending to whenever you are attending to a class, you got a roll number like AWS 01. Okay, AWS 01 is the roll number, or 001. And for the second candidate, I assigned the roll number as AWS 002. Like that, if any student who has joined in sessions, I am going to provide the identity number of Python 01 and Python 002 and Python 003. Like that, I am going to assign the numbers. So when I assign these numbers, and I want the students to enter into a corridor, I want all the students to enter into a corridor and separate based on their classes. Okay, so separate. I want all the students to be separated based on their classes. So depending on what I can recognize that this student belongs to AWS, this student belongs to Python. Because of the ID card, whichever I have given to the student in the ID card, I can clearly mention that Python 001. So now I can understand that, okay, the student belongs to the Python session and his identity is 1, and the other student belongs to Python and his identity is 2. Like that, I can identify. Why? Because I have my brain functioning, so I can simply understand that. But how computers will understand that? So if I give 192.168 some 2.200 and 192.168 1 dot some 150 and 192.168 some 1.100. So all these computers belongs to the same network or different network. How computers will understand that? Depending on what they will understand, depending on the subnet mask. So every IP address will have a subnet mask. Here you can see you are having the, this particular computer is having the subnet mask. Without subnet mask, it is not possible for the computers to understand or else to get to know about this IP address. So what is the subnet mask? Subnet mask is also a 32-bit address. Subnet mask is also a 32-bit address which will divide the IP address into which one belongs to the network portion and which one belongs to the host portion. So for example, I am having a subnet mask like this 255.255.255.0. Then what subnet mask is going to do here is it will divide the IP address, or else it will tell the IP address that, so the first 3 octets are the network octets and the last octet is the host octet. Now how it is going to tell the IP address that the first octet or the network, or first 3 octets are the network octets and last octet is the host octet means, see, when you convert this 255 into binary to, sorry, into the decimal to binary number, again I am telling you, if you convert 255 from decimal to the binary number, you are going to get all ones. So 8 ones, if you convert these 8 ones in the binary format to the decimal number format, you are going to get 255. Here you can see that. Binary to decimal. Sir, in this Terraform session, is it required to understand this? Again, why you need to get a confusion about the CIDR network? So if I explain you, then it will be helpful for you. It is not required, but if you got a clarity on this, then that will be helpful for you know. So see here, if I convert this 8 ones into the decimal number format, you are going to get 255. Okay, again you are having 8 ones over here, and again you are having 8 ones, and this binary number, 0 is in the decimal number format. Okay, so if I want to convert that 0 into the binary number format, I can convert like 8 zeros. Okay, so this is the complete subnet mask, whatever you are seeing right now. So this subnet mask represent, so wherever you are having the ones in the subnet mask, in whichever the octet you are having the ones in the subnet mask, then that octets in the IP address are the network octets. So the first 3 octets of the subnet mask belongs to the network. So it will say that the first 3 octets of the what I can say, the first 3 octets of the IP address belongs to the network, and the last octet belongs to the host. So how in the networking, uh, especially in the subnet mask, one represent, okay, one bit or one binary number represent network, and 0 represents host portions. So now if you see, so 255, 255, 255.0 means, so this 3 portions in the subnet mask represent the network portions. That will tell the IP address that, so the first 3 portions of the IP address belongs to the network, and the last portion belongs to the host. Just like the this example, where is that AWS 01 is there, AWS 01, AWS 02 is there. So AWS is a constant one. In the entire class, every student will get the AWS as a constant beginning identity. And at the end of the number, or else at the end of the identity, you are going to get a number. So every student will have an unique number. So AWS 01, AWS 02, AWS 03, like that. For example, if some 10 students has joined, I will give 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't repeat the number. So like AWS 01, for the other candidate, I cannot provide AWS 01. So if I provide that, then the conflict will occur. In the same manner, in the host portion, whatever the number is there, that number cannot be repeated in the network. So for example, if I take this, the second IP address, for the second IP address also, I am providing the subnet mask as 255.255.0. Now, can you tell me whether these two IP address belongs to the same network or different network? So if you see the subnet mask, the first 3 octets are the network portions, and here also the first 3 octets are the network portions of the IP address. Now, depending on that, can you tell me whether these two belongs to the same network or different network?
It will be different network.
They will be in the different network. So how we are going to say that? So if you see the first 2 octets, it will be the same. But whatever the third octet that you are seeing here, that is a different number. Okay, so here you can see, here you are having 2, and here you are having 1, which means that the networking octets are different. So that's why these belongs to the different network. Okay, so and here you can see the numbers, the last and host numbers are, if you put common in this, like I will go with the 200 also, no problem. Why? Because so there is a student in the AWS which is having the roll number as 200, and there is a student in the Python network or else Python class which is having the roll number as 200. That doesn't matter, no? So if 2 students with the same with the same number identity but different networks, different classes, they won't be affecting that. But if I provide like this, then there is going to be an conflict. So if the 2 IPs are same in the same network, then you are going to get a IP address conflict. So now this is how we are going to define the IP addresses. Whenever we are defining any IP address, every IP address should be created with the subnet mask. Without subnet mask, you cannot create any IP address, or also you cannot assign the IP address to your computer. So for example, if I try to assign an IP address to my computer, so first things, what is going to happen if I try to assign like this? 192.168.0.250. Then if I click OK, I'm going to get a warning or error. So what is the warning? You have entered an address that is missing its subnet mask. Please add a subnet mask. So definitely we have to add the subnet mask. If I don't add the subnet mask, computer will not accept the IP address. So subnet mask and IP addresses are the combination which cannot be, separated. Definitely you need to have the IP address followed by the subnet mask. So why we need to follow it by the subnet mask? Because of the identification of the network portion and host portion of the IP address. Okay, right. So now we have understand about the IP address and subnet mask. Any questions here? Is it clear? I know there are some networking candidates, but anyways, so who are attending to the, who are learning the first time, is it clear?
Yes, certainly. Yeah, that's good.
Thanks.
Right. And now when the IP addresses are like this, so there is an organization who will provide the IP addresses to the entire world, and that organization is called as IANA. Okay, Internet Assigned Number Authority. Okay, so what they are going to provide here is they are going to distinguish, or else they are going to distribute the IP addresses across the world. So if you see for India we are getting the internet. So if we are getting the internet without IP address, we cannot get the internet. So who will distribute this IP address? Means there is an organization called as Internet Assigned Number Authority. They are going to divide the entire world into the 5 different zones. Okay, so what are those zones? Here you can see African zone, Pacific, Asia Pacific, and American zone, that is Canada, USA, Latin America, that is South America, and Republic nations like Europe and what I can say, the Russia and all the things. So if you see what are the IP address spaces for each and every country here means, this is not required, but just go through this. So 01 is given for Asia Pacific, 02 is given for the Asia Pacific. For example, right now I am in India, no? So if you see my IP address, the IP address is, my public IP address is in 42 range. So 42 range is given for Asia Pacific NIC. So if you see my public IP, okay, I don't want to expose it external, but that's fine. IP info.ip. Here you can see this is my public IP 49. 49.204. 49 belongs to which region? Asia Pacific NIC. So which means that they are allocating the IP addresses for the different regions depending on the number system, or else these numbers they are going to divide it. So now what INA has decided here is, or else INA has thought that, okay, so I will provide the IP addresses. So which type of IP addresses that we are getting? We are getting IPv4. So IPv4 is having 32-bit address. IPv4 is a 32-bit address. So the total IPs that are going to be generated here is 4.2 billion, or else 4.25, or else 4.3 billion, nearly equivalent to 4.3 billion. So when I go with the 4.3 billion IP addresses, whether those IP addresses are sufficient for each and every person. So right now, the entire world population is 8 billion. The world population is 8 billion. So the entire, for every person in his hand, there is a mobile phone. A laptop is there, computer is there, and in his home, there is smart TV. And then what I can say, there are so many devices that are connected through the IP address. So then is it possible that 4.3 billion IP addresses can provide the internet access to this 8 billion people? So there will be an IP address. Yeah.
I said no. I thought you were asking.
So that 8 billion IP, so for these 4 billion IP addresses are not sufficient for the people of 8 billion. For example, if you think some 2 billion people are there, 2 billion people in the sense 200 crores of people are there, they don't even know about what is an internet. So rest of 6 billion people is there. For 6 billion people, at least they need to have sufficient IP addresses. But in the IPv4, we don't have those sufficient IP addresses. Now, what INA has decided here is, okay, I will divide this entire IP addresses into 2 special IP addresses. One is the public IP address, public IP, and the other one is the private IPs. Okay, public IP and private IPs. Now, what is this public IP and private IP in the sense? For example, if you are having a company or else an organization or else in your home, so whenever you want internet, what you will do, you will approach to an internet service provider and put a request that I want the internet for my company or else for my home purpose. Now what that internet service providers will do, they will assign a service engineer. So the service engineer will come and install a router in your home or else in the office. Okay, so when he puts some router, or else if you say that we have our own router, you just need to give the connection. So he will come and give the connection in the company. So when he provides the connection in the company, then what is going to happen here is, so there will be in the router, if you see, especially if you see in the router, there will be two types of ports will be there. One is the WAN port and the other one is the LAN port. LAN ports and WAN ports will be there. And if it is a Wi-Fi, normal Wi-Fi router, you can get, if you are having the laptops, you can directly get the internet through the Wi-Fi. But this router, whatever the router is there, so this router will be connected through a cable, and this cable will be coming from a junction box. Okay, so now what will happen here is, whatever the cable that is connected to the router, so it will be connected to the internet. Actually there is another concept, but just for your understanding, it is connected to the internet, and one end of the router will be connected to the WAN port. WAN port in the sense internet port, just for your understanding, I'm saying you like that, but there is a different thing. WAN means wide area network. So you will be connected with a public IP. So in your router, if you check out in the WAN port, when you check out the configuration, there will be a public IP assigned to your WAN port. And the other side, you will be having the private IPs. In the LAN ports, you will get the private IP, and as well as through the Wi-Fi also, you will be getting the private IPs to your computer. So now what is this public IP and what is the private IP? Public IPs are the IPs which are helpful for the computers to communicate with the internet. So if you want to communicate, if the computer wants to communicate with the internet, then definitely you need to have the public IP. Without public IP, it is not possible. Now, in the same manner, what is this private IPs? Private IPs are the IPs which are assigned within the organization so that one computer can communicate with the another computer privately without paying anything for the network provider. So for the public IP, you have to pay. So public IPs are chargeable. But whatever the internally used private IPs are there, so those are free of cost. So if I have to tell you in a simple manner, so you have a pet name in your home, you have a private name in your home. Okay, every relative of your home or else whoever are the persons in your home will call you with that private name only. Okay, with that pet name only. But when you go outside, when you go outside of your home, nobody will call you with that pet name. Everyone will call you with your surname or else with your name that is given to you. So that's the public name, publicly aware or else publicly known name. For example, there is a person called as who is there? Let me take an example here. Yeah, Kamal is there. So Kamal is the name which I can publicly pronounce it. But when Kamal goes to his home, he will have his own private name. So here the point is, in the same manner, whenever your computers are there, the computers will have a private IP address. So the range of private IP address I will tell you within a short span of time. But every computer, if they want to go to the internet or fetch some data, so then the request will go to the router, and from the router, when the request goes outside, so the request will be going on the public IP. So into the router, the request comes from the computer in the private IP address. But from the router, when the request is going outside, the request will be going on the public IP. When it is going on to the public IP into the internet, so from the internet, it is going to fetch out the data and comes back to the router. And this public IP is again translated into the private IP and sent back to the concerned computer. Now, this kind of translation is called as NATing. Okay, so the conversion of private IPs into the public IPs is called as NATing. So in your router, you will have this. NAT means network address translation. So now you have you got a clarity that how this private IPs will be connecting to the public IPs. Now these private IP addresses, whatever the private IP addresses are there, in general, there are three types of private, three ranges of private IPs are there. What are the three ranges of private IPs? Means 10.0.0.02, 10.255.255.255. This is one range, and the next one is 172.16.0.02, 172.31.255.255, and the next one is 192.168.0.02, 192.168.255.255. These are the three ranges of private IPs that you are having. Okay, so now in your computer, if you open your computer, any computer will have this range of IP addresses only. If you check your IP config, so other than these IP addresses, you will not find any private IPs. So in your computer, you will have the 10 series network, or else you will have the 172 series network or 192 series network. So you can check it out. So any which ways, so these are the private IPs that are generated or else that are given by INA. So in an organization, in this organization, I can use 192.168.1.100. When it goes outside from the organization, it will be converted into a public IP. So the same IP addresses I can use in the another company also. So in this company, I am having so many computers over here. So these computers can be assigned with the same private IP, no problem. Same range of private IPs you can assign to these computers. So there won't be any problem. Why? Because whenever it is going into the internet, it will be going onto a public IP. It will be translated. Whatever the private IPs are there, they will be translated into the public IPs. So the public IPs for every organization or for any home, there will be unique public IPs. Okay. But internally, if you are having, so in your home, you are using the IP range as 192.168.1.100. In your neighbor home, they are also using 192.168.1.100 means no problem. You can use 192.168.1 network. Why? Because whenever these IPs, these are the IPs that are internally communicating. But when they are going outside, they will be converted into a public IP, and that public IP will be sent into the internet and get the data back to you. So this is the public IPs and private IPs. Other than these IP ranges, every IP is a public IP. Okay. Now, there are again classful IPs and classless IPs. Even though if they come with then private IP address as a solution for this less number of IP addresses, still they have an issue. For example, there is a company. In this company, there are the company has assigned somewhere like 192.168.1.0/24 network. What is this 192.168.1.0/24 in the sense? See, the slash values represents the number of network bits in the subnet mask. So if you see 192.168.1.0/24 means it will represent 192.168.1.0/24 in the sense it will represent slash values represent number of network bits in a subnet mask. So if you see 24 network bits are there, 24 network bits in the sense you have to divide them into the 3 octets. 24 divided by 3 in the sense 8. So in every octet you are going to get the 8 network bits. So the subnet mask of this particular network is 255.255.255.0. So if you convert this /24 into the decimal number format of the subnet mask, the /24 value is going to come like 255.255.255.0. Why? Because /24 means 24 network bits. So if you see 255 means 8 network bits, 255 8 network bit, 255 8 network bits. Totally, if you combine, you are going to get 24 network bits. Or else, for example, if I am going to give the IP address in this format 192.168.1.0/16, okay, so then the subnet mask will be 255.255.0.0. Like that, you can assign the subnet mask. Any which ways, so this is about the network. So now what happened here? So if the organization inside the organization, they want to divide this organization, they want to divide this /24 network into the small networks, they can divide. So what is the /24? How we are going to divide that? To understand that, first of all, let me introduce you to the IP address and subnet mask already done. But these IP addresses are divided into multiple classes. Whatever the IP addresses are there, IP addresses are divided into multiple classes. So what are those classes? Class A, Class B, Class C, Class D, Class E. These are the 5 different classes the IP addresses are divided. So for any device, we can assign the IP address from the range of class A, B, and C. So we cannot assign class D and class E for the end devices like computers, mobile phones. These cannot be assigned accepting the class D and class E IP addresses. So now how this classes has came? So in the IP address, you are having the number starting from 192, starting from 0 to 255, 0 to 255 in the IP address. I'm not talking about the subnet mask. I'm talking about the IP address. So every octet will be having the IP address in between the range of 192, 0.255.0 to 255, 0 to 255, like that. So now if I convert the highest number into the binary number format, you are going to get all ones like this. So now what is happening here means there is a first octet rule. First octet rule is there. So what is this first octet rule will say? If you convert the if you replace the first number of the IP address, whatever the highest IP address is there, or else highest number is there, if you convert this first number into 0, so what is the value that you are going to get? So the value will be simply, if you see 0, 127 is the value. So if you convert this, so in the decimal number format, that is 127. So then first octet rule will say that in your IP address, or else in class A, the IP address starts from, I will call it as 1 to 126. Even though it is saying that in the first octet rule, you can use 127. 127 is not going to be used in your, it will be used as a loopback address. So by default, 127 is called as a loopback address, 127.0.0.1, or else I will call it as local host. So have you ever seen this local host? Whenever you are checking your application, you might be checking the local host, no? Have you ever checked out that?
If you deploy the app locally, you go through localhost. Yeah.
If you deploy the application locally, you want to check whether that application is working properly on a particular port number, or else are you getting any error on that? You will be checking the local host. Local host is for the testing purpose. So 127 address will be the testing. So if you convert that local host, that is nothing but your 127 address. So 127 address are given for the loopback addresses. So this is called as loopback. Okay. So now for class A, even though the first octet rule will say that the last number for class A is 127, we are not going to use the 127 in the first octet. So if any number that starts from 1 to 1.0.0.1, or else somewhere like 10 dot some 255 dot 240.26, like that. So here also the first octet starts with 10. 10 is the number that is lies in between 1 to 126. So that belongs to the class A only. Okay. So this is what the first octet rule will say. So the first octet rule says that in the first octet, if you put in the maximum number, if you put the first number as 0, whatever the value that you are going to get, that will be the range of your class. So the class A ranges from 1 to 126, even though it says that 127 comes under the loopback address, we can just ignore it. So the subnet mask for this class A, the default subnet mask for class A is 255.0.0.0. So this is already assigned for that class A. So if you see here, whenever I am giving the IP address 10.10 belongs to class A, no? So if you see here, when I say 10.1.250.some 26, when I give 10, automatically what is going to happen? it is taking 255.0.0.0. This is the subnet mask that is going to be taken by your computer or else by your device. Automatically it is taking. I did not provided it, right? So in the same manner, for example, if I provide the number 172, I won't give any second, third, fourth octet numbers. That is the secondary thing. When I give 172, automatically it took the subnet mask as 255, 255.0.0. Otherwise, what I can do, if I give the number 192, 168, then what is happening here? Automatically it is taking 200 255, 255, 255.0. So how the computers are taking 255.0 and like that. So for class A, if the first octet is in the range of 1 to 126, the subnet mask will be 255.0.0.0. So now if you convert the subnet mask into the binary number format, this is in the decimal number format. If you convert that into the binary number format, you will be getting in the first octet, there will be 8 network portions or else 8 network bits or else 8 ones will be there. 8 ones. And in the second and third octet, you will be having second, third and fourth octets, you will be having 8 zeros. So now if you see, this is the binary number format of your subnet mask. So now when you see here, like that you are going to get. So here total how many number of network bits are there? If you see here, there are 8 network bits. So the slash value is called as /8. So depending on the network bit, you can see that there are 8 network bits are there. So that's why it is called as /8. Now how many devices I can, or else how many IP addresses I can generate in this network? So in between 1 to 126. So for example, if I take the one network, 1.0.0.0, this is the one network. So the IP addresses starts from 1.0.0.1. These are the usable IPs, 1.0.0.2. Like that, you can go up to 1.0.0.255. After 255, what will happen? So 256 number will not come. So then what is going to happen means 1.0.1.0. So the third octet will be updated to incremented to the next number. Then 1.0.1.1. So again it will go up to 1.0.1.255. So then what will happen? So there won't be 256 number. So then it will be like 2.0. So and then it will go on, keep on incrementing, and like that what will happen? 1.0.255.255. If you get this number, so the next IP address will not be 256. So the next IP address will be 1.1.0.0. So after 255, what will happen? It will be incrementing the next octet. So the next octet will be incremented. So like that, in the one network only, you are going to get how many host IPs or else how many usable IPs means 2 power h minus 2. 2 power h minus 2. What is h here? H is nothing but total number of host bits in the subnet mask. So if you see total number of host bits means 24 host bits are there. So 2 power 24 minus 2. So that is equal to 1,67,77,216 IPs you are going to get minus 2. Then you are going to get 1,67,77,214 IPs. So these many number of usable IPs will be there if you take any network. For example, if I take 1.1.0.0.0, this is the network ID. Why I am subtracting these two means one will be gone for the network ID and the other one will be gone for the broadcast ID. For example, if a student is joined, did you ever find out the organization is giving the student with the roll number? For example, if you join into the AWS session, AWS 000, or else in your school also in the registration or register, have you ever find out 0 is assigned to a particular student? So the student identity will be starting with 0. No, right? So it will be starting from 1 only. So here, if you see the subnet mask, when you come back to the subnet mask, if you see the subnet mask, you are having the second and third octets or the host octets. So the subnet mask will tell the IP address that the first octet is the network octet and the remaining 3 octets are the host octets. So now in the host octets, if you are having the 0 number, then that is called as a network ID. If in the host octet you are having the 0 number, then that is called as a network ID. Okay. And if you are having 1.255.255.255, if the host octet is completely filled up with the ones, so here you can see the host octet is completely filled with the zeros. So if you convert this into the binary number format, then you are going to get 8 zeros, 8 zeros, 8 zeros. So the host octets are saying that you cannot have all zeros in an IP address. In the host portion, you cannot have an all zeros in the IP address. If you are having all zeros in the host portion, then that is called as a network ID. And if you are having all ones in the host portion, then that is called as a broadcast ID. This is called as broadcast ID. So you cannot assign the network ID and broadcast ID for a computer. So apart from that network ID and broadcast ID, remaining all the IPs are the usable IPs. So here, that's why I have given, what is the number I have given? -2. Why I have provided -2? Because so we are removing the network ID and broadcast ID. You are going to get the usable IPs in that particular network. So we got 1 crore networks in the class A. So depending on the usability, so some organizations may require 1 crore IP addresses. Some medium organization requires some thousands of IPs. Some small scale industries requires only hundreds of IPs. So depending on that, they have divided the class A is, we got the class A with the maximum number of devices or else maximum number of IPs that we can assign. And the range of class A is 1 to 126. And when you come to the class B, the class B will be, so what is after 126? What is the number? 127. Of course, 127 is given to the loopback. The next number is 128. 128 to, in the first octet rule, if you convert the second bit into the 0th number, 1, 2, 3, 4, 5, 6, 7. Yeah. So if you convert the second bit into the 0 number, so then whatever you are going to get, that will be the end number or else the end for that particular class B. That is 191. So the class B ranges from 128 to 191, and the subnet mask will be 255.255.0.0. This is the default subnet mask. So which means that what is the value that you are going to get? So you will be getting 1 dot. So all ones. So how many network bits are there in the subnet mask? How many network bits are there in the subnet mask?
16.
16. So the slash value will become /16. Okay, and total number of devices in this network is 2 power h minus 2. So that is equal to, so you are going to get 2 power 16 minus 2. That will be, so the usable IPs, the total IPs will be 65,536 minus 2. So the usable IPs will be 65,534 IPs are the usable IPs in the class B. So if any computer, if you are seeing any number ranging in between 128 to 191 with the 255 0.0, then that is belongs to the class B. And class C is after 191 you will be having 192 to, so in the first octet, if you convert the third bit into the 0th bit, so then what will happen? You are going to get a number. So that is 223 number you are going to get. 223. So which means that, so 192 to 223, these are the range of numbers that belongs to class C, and the subnet mask will be 255. This is the default subnet mask, 255 255.0. And if you convert that into the all the network portions, I mean binary number, then you are going to get in this format. So total number of network bits here is, how many network bits are there? How many network bits?
24.
24 network bits are there. So 24 network bits and 8 host bits are there. Okay. So this is my, what is the slash value? The slash value will be /24. Okay, /24. And here you can see how many devices I can connect for this network means 2 power h minus 2, that is 2 power 24 minus 2, sorry, 2 power 8 minus 2. So overall 256 IPs will be generated. Among those 256 minus 2, that is 254 IPs are the usable IPs. So like that we are having the class A, class B and class C. You cannot assign the class D and class E IP addresses for your computers, for your end devices. So the range will be, if I have to tell you, I will tell you the range 224 to 239, and for class E, the range will be 240 to 255. So the classes, I mean the total IP, the total numbers are covered. So I said you in the first octet there will be 0 to 255. So if you see 0 means it belongs to the internet. So 1 to 255 it is covered. Finished. So this is about your classes. So if you are having any IP address in this range, and if you are having the subnet mask in this range, then those are called as classful IPs. For example, if you are having a computer and this computer is having 192.168.1.100 and it is having the subnet mask as 255.255.255.0, then this is called as classful IP. Why? Because the IP address belongs to class C, and as well as the default subnet mask is also the class C range. So then that is called as classful IP addresses. But these are something difficult for the people or else for the organizations to manage the number of devices. So again, they got an issue. So I don't want these many number of IP addresses should be misutilized. So they want the this very big networks into small networks again. So how they are going to convert? So that is what we called as classless interdomain. So whatever we are seeing up to now, these are the classful. Now whatever we are discussing right now, those are the classless. Classless, or also I will call it as CIDRs, classless. So what is the meaning of that? For example, you have a very big company. In this company, the company will be assigned, or else inside the company there is a network, and the network is with the IP address 192.168 some 0.0/24. So this is the network that is provided 192.168.0.0/24. Now what is my requirement here is, so the network administrator is requesting me, or else requesting that to divide this very big network into small networks. Small network in the sense, for example, if you are having a very big city, for the governance of that particular city, so there is some population like some 10 lakh people are there in that city. So if you are having a single police station or single collectorate and single post office, then that will not be helpful for you, right? So for you have to divide the entire city into the small portion so that the governance will be becoming very easy. In the same manner, here this entire network is there. So this network, how many devices I can configure? 192.168.0.0 means. So if you see 192.168.0.0 and the subnet mask is /24. /24 means what is the subnet mask? The subnet mask will be 255.255.255.0. This is the subnet mask. So which means that the first 3 octet of the IP address belongs to the network portion and the last octet belongs to the host portion. So now what is my engineer saying here is, so here totally we are going to get 256 IP addresses. Among those 254 are the usable IPs. So total IPs we have to consider. So among these IP addresses, I want you to divide this very big network into 4 subnets. He is asking me to divide the network into 4 different subnets. So there is another concept called as FLSM, VLSM, fixed length subnet masking and variable length subnet masking. That is altogether a CCNA concept. I don't want to discuss over here. But just what is this CIDR? So I'm going to explain you. Apart from /16, can we give any another number? Yes. So how we are going to provide? I am going to tell you about that. So there are 4. So he asked me to divide a very big network into small networks, small pieces of networks. So how many pieces of network he want me to divide? 4 small pieces of network. So if you see this entire organization, organization network, he's asking me to divide it into 4 small networks. So this is one subnet 1, and then you are having subnet 2, you are having subnet 3. Here I will subnet 3 and as well as
Chaitanya.
subnet 4. Yep.
Chaitanya. Sorry if I'm asking us to like lame question, but when you put /24, you only have the last bit for your network, right? Only like 255, 0 to 255 is the only IP you left, right?
Mm.
So how is it becoming a big network? Isn't
See, it's 200 devices are there. Okay. Big network,
okay?
it doesn't mean that thousands of IP should be there. In your company, you are having only some 50 employees are there. If you are assigning /24 means you are using 250 IP addresses. Okay. So for how many computers?
250 computers, right?
It will
Or
generate 250 IPs, but in your company, how many employees are there?
50.
50.
Okay, that's what you said. Okay.
Then that is a big network only, no? Are you catching my point? In
Okay.
perspective,
So
Continue.
what?
in
So
perspective
we
of the
need.
company, I am talking. It is not like, see, if I have to tell you by /16 also, I can tell you by /16. But initial stages, if I tell you related to the /16, you will be confused. So that's why I'm not taking /16 here.
Okay.
We
Okay. The
can divide
concept
the
same.
/16. The concept is same. If I tell you with a very big number, then you will be confused. So if I tell with a small number and go to the big number, then it will be helpful for you, no?
Okay. Okay. Thanks.
Hmm. Yeah. Yeah, somebody is speaking. Sorry, I didn't recognize. Can you come back? Who is that? Prasad, huh?
No, Chaitanya, this is Prasad. I was just trying to say,
Mm.
depending on the requirement, we need to divide the subnet accordingly.
Obviously.
Yeah.
Obviously. Depending on the network, depends on our requirement, we have to divide the networks. That's for sure. But as he's asked me that, if we are having this many number of things, so how we can do it. So
Yeah,
anyways.
this is quite interesting, at least for me. I have come from an app background, so understanding this is like, thank you for explaining.
Okay. So this is the, we require four subnets. So now if you see here, how we are going to divide this, a single network into 4 small networks. So to divide the single network into the 4 small networks, see, again, coming back to the point, now we are going with a concept of FLSM, fixed length subnet mask. There is another concept called as VLSM, variable length subnet mask. So you might ask me a question, sir. For example, I want to divide the network into 4 network portions. If a few portions I can assign for the HR, few portions I can assign for the accounts, few portion of network I can assign for the developers, and the fourth network I can provide it to my managers and everything like that. You can ask me, sir, if in the FLSM the constant number of IPs will be generated, okay, and VLSM we can go with the variable length of IPs. So for today, I am not talking about the VLSM. We are talking about the FLSM only. Okay, so first of all, let us see the requirements over here. So the requirement is that he is requesting me to divide the very big network into 4 subnets. So number of subnets required. Number of subnets required is equal to 4. Okay, so which means that there is a formula called as 2 power n greater than or equal to number of subnets required. So what does this n represent? Okay, what does this n represent? So if you see, this is the default subnet mask given by my administrator or else the network administrator. So if you convert this default subnet mask into the binary number format, you are going to get this particular subnet. If you convert this decimal number subnet into binary number subnet, you are going to get like this. So what is n here? N is nothing but n is total number of host bits that should be converted into network bits in subnet mask. So if you see 2 power n greater than or equal to number of subnets required is 4. Okay. When this condition will satisfy? So if I say 2 power 2, if I give 2 square, then the condition is satisfied. No, 2 square is equal to 4. So either any one of the conditions should satisfy. Either it should be greater than. See, some people will ask me apparently if I say equal to, sir, if I am having 5, if I want 5 networks, then how we are going to do that? So if I make it as greater than or equal to, then it will be very, very convenient for you to understand. So right now the condition is satisfied. 2 square is equal to 4. So which means that how many number of host bits should be converted as a network bits in the subnet mask? So the total number of host bits that are available here is 8 host bits are there. So this 8 host bit should be converted as the, I mean, from the 8 host bits, we need to convert 2 host bits into the network bits. So the latest subnet mask will be, the new subnet mask will be 255.255.255.192. Okay, 192. So when this is the new subnet mask, and the slash value, what will be the slash value? The slash value will become /26. Why? Because total number of network bits are there in the subnet mask is 26. So you will be getting /26. So the next one is how many devices, or else how many IPs. I'm talking about the IPs, including the network ID and broadcast ID. How many IPs will be generated in the small, or else in the new networks, So for that, what you can do here is, there is a formula that is 2 power h minus 2 is equal to total number of IPs in a network, in a subnetwork. Okay, now we are dividing that very big network into small subnets. So 2 power h, what is h here? H is total number of IPs. Total number of host bits. My mistake. In the new subnet mask, total number of host bits in the new subnet mask. So how many number of IPs are there in the new subnet mask? If you see, how many number of host bits are there in the subnet mask?
26.
So if you see, 6.
Okay.
So I'm talking about the host bits. Host bits are only 6. So the value will be 2 power 6 minus 2. So that is equal to 2 power 6 means 64. 64 IPs you are going to get. Minus 2, why we are giving the minus 2? In every network, there will be a host network portion and broadcast ID. Network ID and broadcast ID will be there. So the usable IPs will be 62 IPs. So total IPs that are generated is 64. In every network, you are going to get 64 IPs. Okay, in every network you are going to get 64 IPs. So that is what fixed length. Fixed length means if you divide the very big network into the small networks, in every subnet you are going to get the fixed number of IPs itself. Okay, so here we are going to get 64 IPs. So 64 into 4, what is the value? So total number of subnets required is 4 subnets. 64 into 4, what will be the value? 256.
256.
So here it is, the condition is satisfied. There you go. 255 means total number of IPs will be 256, and the usable IPs, just forget about the usable IPs. So you are going to get 256 IPs. So 64 into 4 means 256. So the condition is satisfied. So now here, so how we are going to divide this small networks? Okay, I am just giving a layman kind of explanation over here. I'm not going into the technicalities. Just to understand this, technically it is a different concept. So for example, in which octet you are having the numbers that are in the combination of ones and zeros? In which octet you are having the numbers that are the combination of ones and zeros? So if you see in the 3 octets, you are having purely all or ones itself, network bits. And in the 4th octet only, you are having the combination of ones and zeros. So now what you will do here is simply, first of all, the constant value in the networking, the constant value is 256. Divide that with the number of networks required. So for me, the number of networks required is 4. So I will divide it with 4. So the value which you are going to get here is 64. Okay. So now what you will do here is, what is this? This is the network ID of the big network. So take the first you take the network ID 192.168.0.0, and then what you have to do here is simply in the network or else in the octet where you are having ones and zeros. So in the fourth octet I need to add the 64. Simply add 192.168.0.64. This is the second network. 192.168.0.128. This is the third network. 192.168.0.192. This is the fourth network. So the end IP addresses will be, so 192.168.0.63. So this is the first network range. If you see, I have divided this very big network into 4 subnets, and the first network range will be 192.168.0.0 to 192.168.0.63. This is the first network range. Okay, and the second network range will be, okay, and the second network range will be here. When I go back, so the second network range will be simply here you are seeing 192.168.0.128. What is the before number? The before number is 192.168.0.127. So take this. This is the second network range. Okay, this is the second network range. What is the third network range? The third network range will be 128. 128 to what is the last number? 192.168.0.191. And the fourth network range will be 192.168.0.255. So if you see here, so this network starts with the network identity. The network identity is like 192.168.0.0 and ends with 192.168.0.255. So this is the range of this particular IP address. So if you see here, the 4 networks will be starting at, the first network starts with 192.168.0.0 and the last network ends with 192.168.0.255. Hence, this entire network is divided into 4 subnets. So this is how you can divide the very big network into small networks. So do you understand this? Any questions? Again, see, this is the layman explanation that I have provided here. Technically, I am not talking about this explanation. There is another concept for this, but I don't want to make you confused about saying all these things in this sessions. These are the sessions which I want to discuss about the infrastructure and everything. But at least you need to understand the CIDR. So that's why I'm saying you how you can convert a small net. I mean, how you can convert a network into small all subnets. So that's why I'm telling you all these things. Okay. Otherwise, there is no necessity of telling all these things. I can simply go ahead into the Terraform and say, follow me, just follow me, put the CIDR blocks, whatever I am putting over here. Okay.
Yeah, so subnets are just logical grouping of the VNet, right? Virtual network. Or...
Yeah. So if you are talking in the Azure perspective, that's it. That's what. Okay, you are getting the Azure into here, but that's fine. So the point is, subnets are the logical networks of an logically divided smaller networks for a very big network. Okay. Right. So this is about the subnetting concept. Okay. So if you see here we are following. So for this IP addresses, you are going to get /26 for every IP address. So any IP address will be like 192.168, 255.255.255.192. So this is what you are going to get for any IP address. The subnet mask will be like that only. So these are called as classless IPs. Okay, classful IPs will be having. So whenever you take any IP address, so if you are having the default subnet mask, then those are the classful IPs. When you come here, these are the classless IPs. There is no class for this. For example, please note it down. 192.168.0.0/16. Simply, if I have to say 192.168.0.0/16, how can you provide that? That is what classless means. 192 belongs to class C and /16 value belongs to class B means no problem. So that is what classless means. Even you can configure like this also. So the total number of, if you say 255.255.0.0, so the total number of devices that I can configure under this network is, so for example, if I go back to the same example 192.168.0.0/16, the total number of IPs I am going to get is 65,000 IPs. So now my network engineer has asked me to divide that into 8 networks. I mean, this is all my requirement. Again, coming back to the point how you are saying that 8 networks are depending on my requirement, is asking me to divide the very big network into 8 networks. So can you do this problem and tell me the answer by looking into this explanation? Can you do this and tell me why? Because if you are able to understand the concept, then whenever I am discussing about the CIDRs in the Terraform, that will be very convenient. Okay, there is a VPC with the CIDR. This is the CIDR. Inside that VPC, he is dividing the subnets into these subnets, small networks. So like that, we can easily understand the concept. So that's why I'm asking you. Can you divide this network into 8 networks? I know the answer. You tell me the answer. Are you doing?
Yeah, I'm
See, explaining the network is not my thought of doing this. I can go with the Terraform also. I don't need to explain all these things apart from saying you the Terraform. Any which ways, tomorrow you don't need to find any difficulty whenever we are discussing about the IP address. So anywhere we are not going to use the CIDRs, but if you remember, that will be helpful for you whenever you are dividing the VNets or VPCs into small subnets. In that place, these will come handy. Otherwise, I can simply say that just to follow my instruction and do the divisions.
So you need these answers like the 8 IP address like groups. you
8
said?
ranges, 8 ranges of IP address. Yeah, 8 ranges of subnets. So, okay, no problem. I will tell you, and you try to do it on your own whenever you got the thing. So the new networks are the new subnet mask will be 255.255.224.0. That is the new subnet mask. Again, I'm repeating the new subnet mask. The new subnet mask will be 255.255.224.0. The slash value will be /19. You are going to get 19 network bits. And the next one is total number of hosts will be total number of devices that you can create in that particular networks is that 2 to the power of 13. So 2 power 13 minus 2. 2 power 13 in the sense 2 power 10 means 1024, 2048, 4096. I think 8192. So these are the devices that you are going to connect in that network. 8192 minus 2, that is 8190 devices you can connect in a single network. And the network ranges will be 192.168.0.0. That will be the starting network. And the next network will be 192.168.32.0. And then you are going to get 192.168. 64.0, 192.168.96.0, 192.168, 128.0, 192.168, 160.0, 192.168, 192.0, 192.168, 224.0. So these are the 8 network portions that you are going to get. 8 network 8 subnets that you are going to get. Okay, so this is about your subnetting. So any which ways we will discuss about the Terraform from tomorrow. So this is the last demo that we have discussed, and from tomorrow onwards, what we are going to do here is we will be discussing about the Terraform, introduction to Terraform, and yeah, that's correct. And we will go ahead into the concept of Terraform. Okay, so this is the last demo. With this, we have wind up the demos, and whoever are interested to join the session, you can enroll yourself today itself. And from tomorrow onwards, you won't be having the free link. You will be having a paid link, or else you have to do the enrollment. And then we will be discussing about the rest of the concepts. Okay, have a nice day, and we'll meet in the next session.
Chaitanya, since we have the group, I do. Is it you kind of mentioned both AWS and Azure? Are you going to strict with AWS, or if the group don't mind, can you explain in Azure? Like when you explain, is that
I will be going into the AWS one.
Okay. Okay, I understand. You have a strict schedule. Okay. I try to follow. I just I'm used to Azure. That's all.
Yeah, I understand that. Anything else, guys?
No, Chaitanya, thank you. Thank you so much.
Thank you all. So that's it. If you are interested, you can join the sessions, and we'll meet tomorrow. So from tomorrow onwards, that will be a paid link. Okay. So you are going to, if you are interested, please join the session so that you will get a link, and you have to join. You have to join into that link. Okay. Right.
Hey, Chaitanya, quick question. So how do we get the links for these demo classes, right? So even if we enroll, right? There was a lot of useful information in the demo classes as well, right? How do we get the video links for those demo classes?
The videos will be directly uploaded into YouTube, or else DURGASOFT YouTube channel, or else if you want, they will share you the Google Drive access for the demos. Okay, you just contact DURGASOFT so that they will share it out. Okay.
Okay. All right. Thank you.
Right then. Thank you.